Problem 70, quantum mechanics. The question is, let sigma is equal to sigma 1, sigma 2, sigma 3, where sigma 1, sigma 2, sigma 3 are Pauli matrices if vector A and vector B are two arbitrary constant vectors in 3 dimensions. The commutator of A dot sigma and B dot sigma is equal to. Here we have to find out the value of the commutator of A dot sigma and B dot sigma. We know that sigma I sigma j equal to 0 when I is equal to j, and this is equal to 2i sigma k e I j k when I not equal to j. First, let us write the commutator of A dot sigma and B dot sigma. This is equal to the commutator of A1 sigma 1 plus A2 sigma 2 plus A3 sigma 3 and B1 sigma 1 plus B2 sigma 2 plus B3 sigma 3. Now let us expand this commutator as the commutator of A1 sigma 1 and B1 sigma 1 plus the commutator of A1 sigma 1 and B2 sigma 2 plus the commutator of A1 sigma 1 and B3 sigma 3 plus the commutator of A2 sigma 2 and B1 sigma 1 plus the commutator of A2 sigma 2 and B2 sigma 2 plus the commutator of A2 sigma 2 and B3 sigma 3 plus the commutator of A3 sigma 3 and B1 sigma 1 plus the commutator of A3 sigma 3 and B2 sigma 2 plus the commutator of A3 sigma 3 and B3 sigma 3. Here A1 and B1 are constant, so that the first term is A1 B1, the commutator of sigma 1 and sigma 1 plus A1 B2, the commutator of sigma 1 and sigma 2 plus A1 B3, the commutator of sigma 1 and sigma 3 plus A2 B1, the commutator of sigma 2 and sigma 1 plus A2 B2, the commutator of sigma 2 and sigma 2 plus A2 B3, the commutator of sigma 2 and sigma 3 plus A1 plus A3 B1, the commutator of sigma 3 and sigma 1 plus A3 B2, the commutator of sigma 3 and sigma 2 plus A3 B3, the commutator of sigma 3 and sigma 3. We have sigma 1, the commutator of sigma 1 and sigma 1 is equal to 0. The commutator of sigma 2 and sigma 2 is equal to 0. And the commutator of sigma 3 and sigma 3 is equal to 0. Therefore, 3 terms goes to 0. Hence, our commutator becomes, the first term is 0. The second term is A1 B2. Now, sigma 1 sigma 2 is 2i sigma k. Therefore, the second term is A1 B2 2i sigma 3 plus A1 B3. This commutator is minus 2i sigma 2 plus the third term is A2 B1 minus 2i sigma 3 plus 0. The first term is 0 and this term is also 0 plus A2 B3 2i sigma 1 plus A3 B1 2i sigma 2 2i sigma 2 plus A3 B2 minus 2i sigma 1 plus 0. Now this is equal to 2i sigma 1 into A2 B3 minus A3 B2 plus 2i sigma 2 into A3 B1 minus A1 B3 plus 2i sigma 3 into A1 B2 minus A2 B1. Now let us go through the expression of A cross B and see what is sigma. Now we can see that the obtained expression is nothing but 2i into a cross b dot sigma. The above expression is equal to 2i into a cross b dot sigma. Therefore, our commutator is 2i into a cross b dot sigma. Hence, we can say that from the given option, option B is the correct option.